Okay. So welcome to today's webinar on PEMEA and its value for public safety answering points. My name is Dimitra Papatsaroucha, and I will be your hostess for this session. I am an associate researcher and project manager at the Hellenic Mediterranean University. And today's webinar aims to reaffirm PEMEA's value and benefits for emergency services, highlight its compliance with EU regulations, and recap its key use cases. We will also discuss security considerations, the role of the PEMEA Registry Authority, and adoption challenges. We have with us today three distinguished speakers. Evangelos Markakis, which is the chairman of PEMEA and assistant professor at the Hellenic Mediterranean University. We have Jorge Forcada, who is a product manager at CESTEL and ETSI contributor for emergency telecommunication standards, and Urban Sedlar, associate professor at the University of Ljubljana, specializing in cybersecurity, cloud computing, and emergency response systems. Before we begin, just a quick note on the logistics of this webinar. The session is scheduled to last 1 hour. If you have any questions during the webinar, please feel free to drop them in the chat, and we will address them during the Q&A session towards the end of the meeting. Also, as I mentioned, the session is being recorded, and we will upload later on in the YouTube channel of PEMEA the recording. Now, let me go through the agenda. So we will have a quick introduction with an overview of PEMEA and its benefits for emergency services. Then we will go through the use cases and regulations. So we will hear about some key regulatory aspects, interoperability, and practical applications like roaming, real-time text, and application integration. And then we will move on to security and RPA aspects, so the PEMEA Registry Authority, and a discussion about security considerations and adoption challenges, followed by the interactive Q&A session. We will conclude with the next steps and conclusion of the webinar with a summary and some closing remarks. So to begin, I would like to introduce our first speaker, Evangelos Markakis, who will provide an overview of PEMEA and its benefits for emergency services. Evangelos is an assistant professor at the Hellenic Mediterranean University, where he leads the Pacifier Research Laboratory, and he has extensive expertise in wireless and broadband networks, emergency communications, and distributed systems. He has participated in over 40 EU-funded research projects and currently serves as the chairman of PEMEA, and his contributions in fog computing, SDN, NFV, and emergency communication architectures have significantly shaped the evolution of PEMEA. So now I would like to give the floor to Evangelos.
Okay, hello from me also. I'm making an introduction to the PEMEA Consortium, and following we will go with the introduction on this specific area. Who can join the PEMEA Consortium? The growth that we have during the years, the benefits, and I will then leave the floor to my good colleagues in order to go in a more technical depth and why we think PEMEA is a solution for Europe in the part of EU interoperability for emergency app. So, what is PEMEA Consortium? PEMEA Consortium is an established NGO in Spain that brings together public and commercial organizations working in the field of emergency service. Our main idea is to maintain and improve the functionality of the PEMEA emergency network, but in general supporting public safety and emergency communication across Europe and the operability of them for the part of applications. Following, we are working on delivering and certifying the level of quality reliability required for emergency service that follows the PEMEA standard. And for this, we have worked with ETSI in the latest year also on creating the first PEMEA plug test operated by ETSI for the network of PEMEA. Our key values is enabling emergency app to connect seamlessly with emergency service across Europe, and our key features is interoperability, accessibility, and compliance. Interoperability, with focus on connecting the emergency app across borders in order to allow users to reach local emergency service anywhere in Europe. Accessibility, with our focus on real-time text, file sharing, video calling, and chat, making emergency service inclusive. But all this cannot be happening if we are not compliant, fully aligned with its standards, and compliant with the European Accessibility Act in order to ensure security accessibility across Europe. Our task as PEMEA Consortium is to keep the list of quality requirements for the communication components and service provided by the PEMEA network updated, assign in turn to one of the PEMEA trusted partners the maintenance of the PEMEA Registry Authority component. We hold monthly meetings in order to discuss with our members and with the core members our strategy on supporting emergency applications and emergency communication across Europe, manage the potential performance problems that are reported from the PEMEA network and try to address with the suppliers the problem and correct them, manage new requests to connect to the PEMEA network, and as always, a focus on increased awareness in an area that is needed across Europe, and provide letter of support for emergency communications initiatives that follows the PEMEA communication standard. Who can join the PEMEA Consortium? We are an open community that we allow third-party service provider, every person and company in the area of public safety, the PEMEA testing partners that are there to help on the interoperability of the PEMEA apps, applications providers in the area of emergency communication, even trying to help in the process of joining the PEMEA network, but at the same time explaining to application providers why PEMEA can benefit their own emergency app. The PEMEA Consortium supporters, the PSAPs, and any other entity in emergency and public safety area, along with NGOs, organizations interested in the public safety that we have multi-registered in this session also. Following how we reached 2025, it was a long process. It was not over one night. We started on March 2018 with the first pan-European mobile emergency application standard, the TSO 113478, March 2018. We improved the same standard and released the second version, 1.2.1, on March 2020. And from that process, we were, along with the people and the service operators across Europe, we have created multiple extensions of the PEMEA standard, like the instant messaging, the real-time text, the SDNet interoperability and shared service, the PEMEA service discovery extension, the audio-video extension, the file exchange extension, and the third version of the pan-European mobile emergency application that will be coming out later on 2025. This growth in the part of standardization comes also with a growth in our deployment status and how we are progressing across Europe. we have in the Finland PEMEA node to be live, following by multiple countries that are currently under development, waiting and being validated inside the PEMEA network. We have Romania, Slovenia, Greece, and some regions of Spain that they are part of the PEMEA network. But also we have multiple countries that have include in their roadmap the PEMEA, and this is good as we will creating a network that will be compliant for across Europe. And latest, we have also worked with Zaraka, which is an app that works in Czech Republic, Austria, Hungary, and Slovakia, enabling the capability of sending data from their app to the PEMEA network. And we are in an early stage in our partnership, but we are progressing and we are progressing fast. Let me go also on some practical benefits and the relevance of PEMEA. Of course, my good colleagues will explain in more detail why it is a practical benefit of PEMEA. We have the ability to update the caller location to be natively supported and updating during the call. We have also the ability to have an enhanced emergency call routing, meaning that PEMEA can ensure precise routing of emergency calls made via app. We have multiple accessibility features like real-time text, files, video, multimedia, and the ability to have sign language interpreters to make the emergency service accessible to people with disability. PEMEA also is not one way. We have in mind that we are living in a world of multiple emergency standards, and that's why we try to have seamless interoperability, not only on PEMEA architecture, but like IMS and DesiNet in the whole. And why we are working and why we think PEMEA is a good solution? Because it is built by natively internet standards, creating the ability to have a connected communication platform that can easily interconnect other platforms like Microsoft Teams, Zooms, but at the same time, our facility can also integrate sensor haptic device inside the emergency service and ensuring a consistent and reliable communication across diverse technologies as we are built from natively supported internet-capable technologies. I will not go further on this. I will leave the floor to my good colleagues that will go in more technical details. I would like everybody, they are welcome, visit our website, the PEMEA website, our LinkedIn and our Facebook page. And also, you are welcome to join us, member. There is no cost associated, but it is good to have you on our community and be part of the PEMEA Consortium board and the meetings that we have every month. Thank you. I give the floor back to Dimitra.
Thank you, Evangelos, for this insightful presentation. Next, we are going to hear from Jorge Forcada. We will discuss the regulatory framework and interoperability aspects of PEMEA. So Jorge is a product manager at CESTEL, a Spanish company specializing in emergency services technology. He also collaborates with the European Telecommunications Standards Institute, contributing to the development of emergency telecommunication standards. Jorge, the floor is yours. Please go ahead.
Okay, let me share my screen. Okay, Good morning, everyone. I'm going to present the main use cases that may be achieved with PEMEA and explain them so that all of you have them clear and understand. So I'm going to present the first use case, which is adding data to a parallel voice call, which is something like what Finland is doing with their application. Then I'm going to present the use case of improving accessibility with over-the-top total conversation, which is using PEMEA as the main communication channel. This is what other applications under development are going to do, like the Romanian or the Greek mobile emergency applications. Then I will explain how this roaming work, because we say that the main benefit of using standards and using PEMEA is that this already existing mobile emergency application may work in different countries. So I'm going to explain how that works. I'm going also to explain the different routing options, which is something that the European regulation is requesting, and it's something that both PEMEA and NG112 may offer to the emergency communications. Finally, I will present some benefits of having PEMEA added in your current infrastructure. So the first use case is the most easy to integrate, let's say, which is there are some mobile emergency applications which allows citizens to register data, like in case of emergency contacts, their address, some medical conditions or things like that, that could help the emergency service to provide the requested assistance. So these applications, traditionally, what they made is sending this information to a server connected to the 112 of the region where this application is developed, and they made a voice call, a 112 voice call, using the default device dialer app. So this voice call goes with the traditional telephone infrastructure with the mobile network operators and is received by the 112 in their PBX or their IP PBX, and they attend the call. And they can check if the call has been made with their app. They will also receive caller data and they can pair it together. The problem with these applications is that, of course, this data is only sent to the server with which the application is connected. So when this application is used in a foreign country when traveling, the 112 of the country where the application is traveling will not receive the data. Okay, because it goes always to the original country. So evolving and adapting these applications to send this data with PEMEA instead of directly ad hoc to the server allows them to work in not only in the original country, but also in any country that may receive and understand this PEMEA standard data structure. So evolving one of these applications or making a new one that wants to make the most basic use case, which is calling through the mobile network operators channel and in parallel sending data about the caller. This data may be routed even in roaming and delivered to the country where the application is. So this improves this application to be able to work in different countries. Then we have the second, maybe more complex and more advanced type of use case, which is during these years, there has been a lot of standardization work in process, and PEMEA has received a lot of extensions because it's a protocol that may be extended with different functionalities. So it has received extensions for an audio video, which is a video call communication channel, for a real-time text communication channel, but not only that, also an instant messaging communication channel, which is not a real-time text, but like a chat like WhatsApp, and a file exchange communication channel that allows emergency services to send to applications files with instructions, things like that, or the applications to upload photos or videos of the scene of the incident. So how these extensions of PEMEA works is an application maybe want to use these communication capabilities in order to communicate. So the application can send an emergency request with the PEMEA standard data structure saying that it supports and wants to use these communication capabilities. That PEMEA request will go to the best PSAP that can cover it, the PSAP providing service in the area, and it will accept an answer with which of these capabilities are supported by the PSAP. So the application can know if PEMEA is available in the area and which of the standard capabilities are provided by the PSAP in the area. This allows also that an application with these standard capabilities may work not only in their country of origin, but also when traveling, and PEMEA is also supported by the PSAP in the country where the application is traveling. And by using standards, this ensures that any application coming and using these standards maybe work from here or in the future. So all this communication, once established, are hosted in the PEMEA media servers that are hosted by the 112 of the region that is providing the assistance. And all the security aspects for the applications to be able to access and to communicate in these services, in these media servers hosted by the 112, are specified also in the standards, so that those could be used by any application complying with this standard. So I'm going to speak now about how this roaming works, because as I was saying, the best improvement that PEMEA can offer with the standards is the ability for applications to work similarly how they were working in their country of origin, but also in other countries where PEMEA is available. So how this works is each application is connected to a PEMEA AP application provider node. This integration is not standardized, but so each application provider node can be integrated with each mobile application, and the PEMEA application provider node is responsible to know when an application is willing to create or to start emergency communication. Once an application wants to start an emergency communication, the PEMEA AP or application provider node is responsible of generating the PEMEA standard data structure that will be sent to the PEMEA network. This is sent to their associated PSP node, and that node will, if it's associated with a PSAP in the region, will decide if the emergency request is made for in that region. And if it's made outside of their area of scope, it will check in a routing table of other known PEMEA nodes, and it will send to the best possible ASP, which are the routing nodes of PEMEA. So in this scenario, when an application is traveling to a different country and wants to make a PEMEA emergency communication, independently if it's the first use case or the second use case. So independently if there is a parallel voice call or if it's using PEMEA as main communication channel, it will send this request to the PEMEA AP node of its original country, which will then connect with the PSP, and it will send to the PEMEA nodes of the country where the application is. This will be received and accepted by the nodes of this PSAP. And once accepted, this final node will communicate with the AP node of the original country, which will provide the application the needed tokens and security aspects needed and addresses so that the application can communicate with the 112 in the PEMEA media servers that are hosted by the 112 of the country where the application is located. Okay, so this is basically how this routing works. And this can work because all the nodes know how to behave and how to secure the information as it is defined in the standards. Then this routing is usually based in location, but the European regulation is requesting that all emergency communications can be routed not only in location, but in other things like languages, disabilities, or requested service, and so on. All of this can be done in PEMEA because the PEMEA data structure uses the same data structure that is used in NG112, which is data structure the PID-FLO. And this data structure contains all this information, so the routing nodes of PEMEA can be configured to deliver the PEMEA emergency request to one node or another, depending on these properties. So, for example, if a country has different call centers for police, for General 112, for firefighters, and an application prefers to be to contact with firefighters, and that country receives a PEMEA emergency communication, the routing node can decide, okay, it's mainly for firefighters, so it can route to the node connected to the call center of the firefighters, for example. Okay, and finally for this presentation, some words about benefits of having this PEMEA communication interface added to your 112 or your PSAP infrastructure. So adding this communication channel ensures that you can receive emergency communication for existing emergency apps in Europe. I know emergency apps are not now the most used way, the most common way to contact emergency services, but they are popular among people with disabilities. And if this PEMEA is integrated in more countries, it will be more important for existing applications like WhatsApp, Microsoft Teams, etc. We have had some conversation with Microsoft Teams, and they see the integration with PEMEA possible. They are waiting for more countries to be able to receive it in order to move that. So adding this communication channel provides your 112 ready to receive any emergency communication for any PEMEA compatible mobile application that adds to this PEMEA network in the future, because it's based on standards, so it will be compatible in the future. It enhances accessibility because allows you to have total conversation now without having to wait for evolutions in the infrastructure. You know, this video conversation will take too long to be provided by the mobile network operators, and with this you can have today real-time video streaming of the scene of the incidents using PEMEA applications. And well, and all the security aspects are covered by the standards, so you can be secured and ready for the future. So I will leave the floor for Dimitra to present Sedlar Urban, which has other presentations to present. Thank you very much.
Thank you very much, Jorge, for outlining these crucial aspects and main use cases. Before moving further, I would like to encourage all participants to drop any questions that you may have in the chat so that we can visit them later on in the Q&A session. And our speakers will be able to address them. So moving forward, I would like now to invite Urban Sedlar to discuss about security, the PEMEA Registry Authority, and adoption challenges. Urban is an associate professor and principal investigator at the University of Ljubljana, while his research focuses on cybersecurity, cloud computing, and emergency response systems. Urban, the floor is yours.
Thank you. Thank you. So I want to first say a few words about compliance with ETSI regulations. Now, in this short presentation, I will try to outline what these regulations are, what they require, and how PEMEA complies with these requirements. And to give you the short answer now at the beginning, PEMEA fully complies. So it basically provides all of the supported features, all of the features that are required by regulations. And one of the ways for you to get full compliance today is actually adding the PEMEA support to your PSAP. So let me go into more detail now. We have three pieces of regulations that touch the emergency services. So we have the European Electronic Communications Code of 2018. We have the European Accessibility Act of 2019. And now we have the Delegated Regulation of 2023. And the objective of all of these is to ensure compatibility, interoperability, quality, reliability, and continuity of emergency services across Europe. And in addition to that, to ensure that all users, including the ones with disabilities, can access emergency services seamlessly. Now, this is something that actually there's about 100 million people with disability in Europe, and that's a large proportion of the European population. So the target market, this is huge. Now, to outline these three pieces of regulation, what are the differences? What's the nature of each of those? So the first two that I mentioned are actually directives, which means that they need to be transposed into each of the member states, into the national laws. Now, the last one, this is a regulation that is actually enforced across all of the EU member states without transposition. And each of those, of course, has its own compliance deadline. Now, this one is the closest to us, June 28, 2025. This is when the compliance needs to be achieved for the European Accessibility Act. And for the delegated regulation, that date is going to be 2027. Let's just take a brief look at each one of those. So, as I mentioned, European Electronic Communications Code, this is a directive, so it needs to be transposed. And regulates all of the electronic communications networks and services in the EU. And of course, 112, the emergency communication, is just one aspect of broader communication, and of course falls into this category. So member states, according to EECC, need to ensure that users with disabilities have equivalent access to emergency services, and that, of course, includes roaming, which means when they are traveling abroad. Now, for the next one, European Accessibility Act. This is also a directive, also needs to be transposed, and it establishes minimum accessibility requirements for general use goods and services, which of course means it's very broad. It covers everything, all of the services, all of the devices, and of course, this again includes emergency services. So for emergency services, they need to enable real-time text alongside voice communication. They need to enable total conversation, which means supporting also video. And they must allow transmission of emergency communication to the most appropriate PSAP. Now, on the side of the PSAPs, it actually requires that emergency calls must be handled by the same mode of interaction that was used to initiate them. So let me show you what real-time text means. They describe it as text at voice-like speeds. So this is actually a screenshot of a recording of what this looks in practice. So you can see that the user is typing a message, and character by character, the PSAP can see what's going on, so they can react faster quicker, and save precious seconds. And the same goes, of course, in the other direction as well. So now you can see that the PSAP can actually start reacting, and they can both type at the same time, and they can both read at the same time. Now, what is total conversation? This is simultaneous video, voice, and text services. This has also been standardized in multiple ways, but it allows the conversation, total conversation allows the participants to see each other, hear each other, and also use text to interact, or any of the combinations of these modalities. Now, the European Accessibility Act has a timeline, as we mentioned. June 28, 2025 is when the enforcement of the measures starts. And by that date, all of the devices with text capabilities should be able to support RTT, and all of the devices with cameras should be able to support total conversation. And now finally, the delegated regulation. This is the one that actually goes into enforcement by 2027, requires that there is a possibility of interactive two-way communication between the user and the PSAP. It requires accessible communication without prior registrations for roaming, which means for users going abroad. It requires the communication to be free of charge, to be forwarded without delay to the most appropriate PSAP, and to guarantee user location. Now, let me say a few words about how PEMEA covers these aspects and how it complies with each of those. So PEMEA supports multi-channel communication, which means it supports RTT, it supports voice and video, and it supports the user to select the modality, what they're going to use, what's their preferred channel. It supports sign language through video, and it supports relaying this video to sign language interpreters. It supports, as we mentioned, real-time text for nonverbal communication, and it supports, as Jorge has already mentioned, transmission to the nearest PSAP. This is based on different metrics, different features of the PSAPs that are advertised, such as location, capabilities, supported languages, and so on. And last but not least, PEMEA is also aligned with European Electronic Communications Code. It allows accessibility for people with disabilities. It provides many ways for interoperability, as we're going to hear later. And it supports roaming users. Now, let me say a few words about roaming, what roaming means in this context. So PEMEA standard has no concept of user registration. So basically, there is no registration happening anywhere. But as you see here, the user basically can input some personal data. But that data is not a registration. It doesn't go anywhere. This is just a local profile in the application that is collected so it can be quickly transmitted to the PSAP. But it's not transmitted until the emergency call happens. So basically, this is just configuration of the application to save some precious seconds when the emergency occurs. And once the profile here is filled out, this application is basically roaming ready, which means, of course, in a different picture, a little bit different than the one that Jorge has showed, when the user travels abroad, the message for help always gets first to the home server in the home country, and then it is routed through the PEMEA network and finds the nearest PSAP. And in this message is all of the information that the user has provided. Okay, so with this, I'm concluding the talk on regulation and giving word back to Dimitra.
Thank you. Thank you very much, Urban, for the presentation. We can now move on into our Q&A session. So we encourage the participants to drop their questions in the chat so that we may discuss them.
Sorry, Dimitra, sorry to interrupt, but I
Yes.
think there are at least one more presentation I have for the PRA, which we have not talked about yet. Let me intervene before.
Yes, you're right.
I
We
also
can
had one
move
more.
on with this one.
So you want to skip this one and go directly to Jorge now, or?
No, you can go first, Urban, I think.
Well, I just have a few words about the interoperability. So why interoperability? I want to discuss briefly how PEMEA supports interoperability and what we've done in this front. I'm going to just take 5 minutes. So why interop matters is because emergencies can happen anywhere, and citizens should always get help via their preferred method. And this should work at home and abroad when roaming. And this can save lives. This is a fact. And also, last but not least, interop is also required by the regulation. Some of the regulation that we mentioned requires interoperable solutions, including EECC and delegated regulation. So what PEMEA is doing here, it tries to attack things on two fronts. So you know that Europe is massively deploying NG112, IP-based emergency services. And this is IP-based emergency calling that's going to be standardized, but it's a very comprehensive, elaborate, and complex process. So it's going to take a long time, be expensive, and so on. But on the other hand, PEMEA is a really lightweight alternative for some specific use cases that's based on web technologies. And the fact that it is web native means that it's already supported in most modern browsers. It already has full support that you've seen for all of the accessibility features. It's quick to deploy. It's basically just a couple of HTTP calls, so any web developer can approach this integration. And it has provided seamless integration pathways for NG112. And it's done that in a pretty significant manner. It's actually standardized how PEMEA can and should interconnect with NG112. So this is the standard TS103755. You can find it on this link below, and it provides a formal blueprint for how to connect both systems. And this basically means that PEMEA messages can become first-class citizens also in the NG112 ecosystem. So just a picture of how this works. So as I mentioned, PEMEA uses web-based protocols. This means HTTP, WebSockets, WebRTC, and so on. So this needs to be somehow converted for the ESINIT, for the NG112 systems. And this is done using two elements. One element is interconnecting and converting the control messages, which means translates between PEMEA and SIP. And the other one is converting the media, which means it's in charge of converting WebRTC to RTP media. So by using this in a standard way, basically full compatibility can be achieved, and the integration is seamless. So just a picture of how this works. So this is PEMEA to PEMEA native communication, goes like this. But when you have NG112, the final element actually first finds out where to send the messages and then sends the messages to the converter that converts the messages for the NG112 PSAP. And finally, media is established. Media flow is established. This has also been demonstrated 2 years ago at INA conference already. So it's very much possible and very much works in practice. Now, PEMEA is really heavy also on standardization and testing. And we've had our first ETSI plug test last year. This is a test that's actually supported by ETSI, happening in Sofia Antipolis. And at ETSI Plug Test, different vendors can compare their solutions, check the interoperability. And this has been really comprehensive, has gone into a lot of detail to check all of the possible variations. And we see this component is really, really beneficial to the ecosystem and also to possible future integrations with NG112. So to conclude my part here, we've seen that PEMEA supports pretty much any interoperability mechanism. It's based on web technologies and it's really open to integrations, but it's also standardized interconnect with NG112. And by deploying PEMEA, what you get today is all of the accessibility features required by law and a modern web-based solution that can interconnect with anything that you have. So giving my word back to Dimitra.
Thank you very much, Urban. Should we now move back to Jorge? Is there
Yeah.
another presentation? Yeah, great.
Yeah,
The floor is
thank you.
yours. Please go ahead.
Okay, let me share. Okay, here. So let's explain how this PRA, what it is and how it works, because this is what makes the routing in PEMEA be able to work between countries. And it's a key security aspect for the PEMEA network. So I'm going to say what it is so that you can understand this component. I will explain the current status, how is it managed, and next steps for this component. The PRA means PEMEA Registry Authority. It is one of the functional elements described in the PEMEA standard, the TS103478. And it is used to ensure that all PEMEA nodes only make and accept requests to and from trusted nodes. So this means that a PEMEA node which is exposed to the internet in order to receive PEMEA emergency requests from from applications or from PEMEA nodes in other countries should only accept requests for nodes that are registered in this list. This ensures that these nodes are secured and only accept requests from nodes that has been validated that are behaving like the standard mandates with all the security aspects and so on. It also means that if you have a node that send emergency requests to other countries, you should only send requests to nodes that are validated here. So how does it work in reality? The PRA is a publicly accessible component that also only accepts requests from nodes registered on it. So a node has to be registered by the PRA manager in the PRA database in order to be able to retrieve the information of the other registered PEMEA nodes. So PEMEA nodes, as the standard dictates, shall periodically request this list once a day or depending on the frequency, in order to know new nodes that are added to the network or nodes that are removed because they are no longer operating, they were malfunction or by any other means. So this PRA is currently being managed by us, by the PEMEA Consortium. It is a server which has a database behind where all this information is stored. It only accepts requests for entities that are registered there. It, of course, uses HTTPS. And in order to add or remove entities here, the PEMEA Consortium must connect with a VPN to the service and edit this database in order to modify the information that is out there. So in order to add new entities to this database, there has to be the new nodes that are going to be added have to be tested. This is done by a testing partner of the PEMEA Consortium, which makes some roaming tests in order to test that the available PEMEA capabilities of the PEMEA deployment are working as expected and are working as the standard mandate. Once the test has been passed with success, the nodes can be added to the PRA once the provider of these nodes wants to go to exploitation and to open to the general public. And at that point, all the other PEMEA nodes that are operating will know that new nodes have been added to the network. So in the same way that nodes are added, there has to be a procedure to remove nodes that are malfunctioning. So if any of the operator of the PEMEA nodes that are in exploitation detects that it is receiving PEMEA emergency communications from a node that has things that are not compliant with the standard, that, I don't know, is receiving calls from users without identification, any kind of misbehaving of other PEMEA nodes should be reported to the PRA manager. In this case, it's the PEMEA Consortium, with the evidences, and this information will be analyzed. The operators of the nodes will be contacted, and these nodes can be removed from the list so that meanwhile the problem is fixed, so that the misbehaving of PEMEA nodes in one country do not affect other country with, I don't know, malfunctioning emergency communications and so on. So next steps for this PRA is the two key improvements would be adding not only the country or region which the nodes are serving to this PRA, but also the geographical area, so that all registered PEMEA nodes may know exactly which geographical area other PEMEA nodes are offering service to. This will allow, if in the future there are a lot of nodes adding or being removed from the network because there are potentially a lot of countries making modifications and so on, it could be interesting that nodes are automatically configured. This is not something mandatory, but in order to achieve something like that, we will need to add more information to this PRA, because otherwise it will be very, very hard for nodes to know if a node is entering, which area of service the node is providing. Another thing to improve is all these, when I say that PEMEA nodes should only make requests to and accept requests from nodes that are registered here, how this works is checking the certificates, the TLS certificates that are done, that are used with the request. This means that each certificate has been provided for a certain domain, and those domains are the ones that has to be registered here. So an entity should not accept requests from servers that are making the request with a domain that is not registered in this PEMEA Registry Authority. Another issue that could potentially happen is that an application or a server does not have the CA, the certification authority of one of these certificates inside of the local registry of certification authorities. So it could, because for example, some countries sometimes have certification authorities that are only used in the country or things like that. So the standard says that the request shall be done with commonly known and commonly trusted certification authorities. But in some countries or in some scenarios, these certification authorities could not be trusted by some operative systems. So adding here in the PRA the certification authority that have emitted the certificates of the PEMEA node would allow other PEMEA nodes to add these certification authorities to their locally trusted certification authorities and ensure that there is no issue of communication because of not trusting the certification authority of the certificates of the other entity. So it's an improvement in order to be more resilient for the future. And finally, the PRA actually is, as I said, a server with a database behind, but it could be improved to have graphical interface so that is easier to manage and does not require a technician in order to make modifications to it. So it's more easier to use and to manage. And another thing, which is an open topic, is the managing of this PRA is now being done by the PEMEA Consortium, but it's not something that should be done by the PEMEA Consortium in the future. If there is a public agency that wants to take the responsibility of managing this, like European Commission or European Union at some point, it's something that we as PEMEA Consortium will analyze. We are totally open for that. And in any case, in order to add or remove entities here, there will be some testing partner of the PEMEA Consortium involved in order to validate the nodes before adding and removing nodes here. Okay, so that's all from my part. I leave the floor to Dimitra.
Thank you very much, Jorge. So I don't think that we will have time for a Q&A session. However, if the participants have any questions, they can always reach the PEMEA Consortium through its social media, in Facebook and LinkedIn, also through its website. So we would like to encourage you to reach out to us or if you have any questions or if you're interested in further collaboration. At this point, I would like to thank all our speakers for their valuable insights today. Before we close, let me summarize the key takeaways from this webinar. So, PEMEA provides a crucial framework for ensuring localized emergency application interoperability, allowing accurate user information to be delivered to the appropriate public safety answering point. Also, compliance with EU regulations ensures that PEMEA aligns with existing emergency communication requirements, and security and PRA considerations are fundamental to PEMEA's adoption and long-term sustainability. The recording of the webinar will be uploaded to the YouTube channel of PEMEA, so you will be able to revisit that. And once again, thank you to our speakers, Evangelos, Jorge, and Urban, and all of you for attending today. Have a nice rest of the day, and we look forward to seeing you in a future PEMEA event. Thank you very much.